call again. You drive me nuts.
I recycle it.
So, you guys going to answer the question today. And we're going to work on our lab. And it's going to be easiest if you do partner up with somebody. But you may work alone if you wish.
I work with my skills.
No. But you guys are going to need a coin today. Okay. So, everybody should have answered the daily question. Today, what we are going to do is we are going to work today, and we'll probably need tomorrow as well. We are going to we're going to do the Create a Baby Lab, okay? So I'm going to read this to you, and this is the only babies I want you guys making, okay? Just the ones we're drawing in here, no real babies, okay? Not till you're like 30. You want to be 30s because, you know, like live longer, you know, finish high school, finish college, get a good job, travel, see the world, do all the fun things that you can't do once you have kids. Well, I haven't seen half the world yet, so. Okay, ready? Let's look at what this lab is. Listen, because I don't want to have to explain it multiple times. Create a Baby Lab. The purpose, to demonstrate that genes and traits are passed on from generation to generation. The concept of dominance, genotype, phenotype, and incomplete dominance will be illustrated. What you're going to need, you're going to need the lab sheet, you're going to need colored pencils or crayons, and you're going to need pennies. Procedure. Easiest if there is 2 people. If there is not 2 people working together, what you're going to need to flip twice. We need 2 people because 1 student will be the mother and 1 student will be the father. What you are going to do is determine the genotypes for each trait of the baby by flipping the pennies. So, like, what will the eye colors be? What will the hair color be? Will they have a round face or a square face? We have a whole big list of traits that we're going to determine what the baby will have based on how you flip the coin. When you get a heads, it is a dominant trait. When you get tails, it is a recessive trait. Remember, heads are represented by dominant heads is represented with a capital letter. Lowercase is recessive, so that will be tails. Record the genotype and trait on table 1. Remember, 1 gene is from the mom, 1 gene is from the dad. So when you look, the last page is your chart, okay? And you can see the father's genes, the mother's genes, and then the traits that they actually get. So number 4, upon completion of the genotype and phenotype, draw your baby and with the colored pencils or crayons. It has to be a color drawing at the end. So there's 2 parts to this. Completing the traits worksheet, and then on the back of the traits worksheet where it's blank, you can draw the baby. So on the back sheet, you draw the baby. Now, really, you can just draw the face of the baby. You don't have to draw the whole body, but it should be large enough that I can see everything. So you want to take up the whole paper. Upon completion of the genotype and phenotype, draw your baby. It's important to remember to draw the baby and not an adult or a child. We're looking for a baby image here. And it needs to be color because you're going to determine the eye color and the hair color. So you have to color it so I know what traits you got. The other thing that's important to know is about gender, and we haven't talked about that yet. When we talk about gender, females are represented by XX. They have 2 X chromosomes. Males are XY. So it is actually the men, the fathers, who determine the sex of the baby. Because all girls can pass on in the egg cell is an X chromosome. Males get to pass on the X or the Y chromosome. They could pass on either one of those. So the dads are the ones who determine the gender of the baby. So here, the very first thing that you're going to do is whoever is the dad is going to flip the coin. So gender is determined by two chromosomes. Males have an X and a Y chromosomes. Females have two X chromosomes. The father can either give an X or a Y chromosome to his child. Well, the mother can only give the X chromosome to her child. Knowing this, you okay over there? Knowing this, the gender of the baby is determined by the father. For this characteristic, only the father flips the penny. If heads comes up, the father gave a Y chromosome to the baby, meaning that the baby would be a boy. If tails is flipped, the father gave the baby an X chromosome, meaning that the baby is a girl. After you know whether you have a boy or a girl, now you need to name your baby. Okay, so that's how we're going to do this. Okay, so, but what I want you to make sure that you do is, like when you're looking at like the first one, now you need to make sure you're using the correct letters, because if you flip through this packet with all these different traits, you're going to see that each trait has a different letter. Okay, so when you look at face shape, we're going to flip the coin. Flip your coin. I got heads. So yeah, I'm going to give you a coin. So that would mean I got a capital R. So if I'm the mother, I'm going to go to my chart, and where it says face shape, I'm going to put a capital R. Okay. The dad would then flip the coin. I got another head. So on my chart, I'm going to write another big R where it says father. In the last column, I'm going to put those together. Big R, then I'm going to put a dash. Two big R's gives me a round face. So I'm going to write on my paper, big R, and the trait is round. So that when I go to draw my baby, all I have to do is look at this last column and know that I have a round face. Now, the only thing that is different is when you get down to eye color and hair color. When you flip for eye color and hair color, there is more than one gene that codes for eye color and hair color. Okay? So what you're going to have to do is you're each going to have to flip twice. You will get an A and a B. So I would flip. I got heads, so that's a capital A. Okay? I'm going to flip again. I got a lowercase, so that's going to be B. So my traits would be, for the mother, would be A, B. Now I'm going to flip for the dad. When I flip for the dad, I got another big A. I flipped again, I got a big B. So these are what my parents look like. I've got big A and a B, small b for mom, and for dad I have a big A and a big B. I'm going to bring those back together for the baby. I'm going to put the A's together and the B's together. So my baby, their genes are big A, and big B, little b. When I look at my chart on the second page for hair color, big A, big B, little b gives me black hair. So my baby has black hair. And this is because we have two things going on. We have more than one gene that codes for this. And in some cases, we might have incomplete dominance where we have more than one gene being expressed. You guys need to work through this, read the packet, do your flipping, then draw your baby. Do you guys have any questions? Yes? No. Okay, partner up. Go ahead, get started, and make a baby. The only time I'm ever going to tell you to make a baby. And not a baby in real life, just a baby on paper. No babies for you guys until you're 30.